In this video, we're going to be going over a molecular view of water and also water bonding. And this is our part 17 video inside of chemistry, chapter 2. And in our last video, which was part 16, we went over the basic concepts of water and also water bonding. And in today's video, we're just going to be going over a quiz and also some practice problems for all the things that we learned in our last video. So let's get started with this part 17 video. So we're going to start things off with checking our understanding. So for question number 1, compare and contrast covalent bonds and also hydrogen bonds. So what's the differences and also some similarities between them? So for question number 1, we need to compare and contrast covalent bonds and hydrogen bonds. So take a moment to pause the video to try to solve all these questions that we're going to show by yourself, and we're going to go into the solutions right now. So for question number 1, so covalent bonds are strong bonds formed when two atoms share one or more pairs of electrons, and they occur within a molecule to hold the atoms together. So for example, covalent bonds are always formed when there's a nonmetal with a nonmetal. So for example, and the most common example that we can use is water. And in contrast, hydrogen bonds are much weaker and involve the attraction between the positive side of one molecule and then the negative side of another. So for example, if we had water, in the case of water, a hydrogen bond would basically be, so this is one molecule, this is the red one is the oxygen, and these two white ones are the hydrogens. So a hydrogen bond would basically be where one of these hydrogen atoms touch another molecule's oxygen. So basically it would be like this hydrogen bond. So basically it would be this one hydrogen atom touching this red one from another molecule, and that would be a hydrogen bond. So this is the difference between covalent bonds and hydrogen bonds. For question number 2, how does the shape of a water molecule contribute to its polarity? So once again, take a moment to pause the video and try to solve this by yourself. And now for the answer. The shape of a water molecule is bent due to the larger oxygen atom having two pairs of unbonded electrons that repel to the bonded hydrogen atoms. And this shape causes an uneven distribution of charge with a partial negative charge on the oxygen atom and a partial positive charge on the hydrogen atoms, leading to a polar molecule with a positive end and also a negative end. So because of this bend shape that these water molecules have, it allows the oxygen atom to have a more negative charge and these hydrogen atoms having a positive charge. And moving on to question number 3, list 5 physical properties that distinguish water from most other compounds with a similar molecular size. So for the first property, we have high boiling and melting points, and this is due to strong hydrogen bonding. For our second property, we have liquid at room temperature, whereas most similar sized molecules are gases. And a common example would be methane. So even though they have almost the exact same size and also the exact same weight, methane is gas at room temperature while water is liquid. For our third property, we have high heat capacity, meaning that it can absorb a lot of heat without a large change in temperature. For our fourth one, we have high surface tension, which allows insects to walk on its surface and water to form droplets. And finally, for our fifth one, we have expansion upon freezing, which causes ice to be less dense than liquid water. For question number 4, what is surface tension? And use the concept of surface tension and hydrogen bonding to explain why water forms droplets on the surface of a car after a rainstorm. So surface tension is a property of the surface of a liquid that allows it to resist an external force due to the cohesive forces among the liquid's molecules. So water has a high surface tension because the hydrogen bonds pull the molecules towards each other, which minimizes the surface area. And for the answer of the second part of the question, which was why water forms droplets on the surface of a car after a rainstorm, and the answer for that is after a rainstorm, water forms droplets on a car surface because of the cohesive forces within the water are stronger than the adhesive forces between the water and the car's surface. So basically, the water has a stronger cohesive force compared to the car's surface, which allows it to form water droplets onto the car's surface. And moving on to question number 5, why would it be unwise to store a completely full glass of container of fruit juice, a water-based beverage, in the freezer, and use the same concept of hydrogen bonding inside of your answer? And would you have the same concerns about storing an oil inside of a glass container in the freezer? So for this, storing a completely full glass of container of fruit juice inside of the freezer is unwise because water expands upon freezing. So basically this is because of the formation of ice. Since water expands into ice, it's going to basically break the glass container inside of the freezer. And if we were to add oil instead, it would generally not form hydrogen bonds in the same way as water does, so it would not expand in the same way. So you'd be safe to store oil inside of a glass container inside of the freezer. For question number 6, thinking critically, as shown on the right, a molecule of ozone, which is O3, has a bend shape like a water molecule. So is ozone likely to be a polar molecule? And explain your answer. So ozone, which is O3, is likely to become a polar molecule because it has a bend shape similar to water. So if any molecule has this type of a bend shape, most likely it's going to be a polar molecule because this bend shape allows there to be a positive and negative charge and also two different poles. So this shape can lead to an uneven distribution of electrons, which in turn creates regions of partial positive and also partial negative charges, and this also gives the molecule a dipole movement. So furthermore, for question number 7, the following photograph shows what happens when water is placed inside of a glass tube. The water molecules are attracted to one another by hydrogen bonds, and they're also attracted by hydrogen bonds to the oxygen inside of the glass. So which hydrogen bonds are stronger? Explain your answer. So basically this question has two different parts. So is the hydrogen bond inside of the water stronger, or is the hydrogen bond inside of this glass tube stronger? So inside of this glass tube, the water would be going towards the edge. So it would be going upwards towards the edge because of the hydrogen bonds. So the question is basically just asking, is the hydrogen bond inside of the water stronger, or hydrogen bonds that is touching the surface or the sides of this glass tube stronger? And explain your answer. So for the answer, the hydrogen bonds between the water molecules are strong. So inside of the water molecules, they are very strong, but the hydrogen bonds between the water molecules and the glass are even stronger. And this is because the glass surface provides a large stable structure with many sites for potential bonding, leading to the concave arc that water forms inside of the glass. So that summarizes everything for this video. So thank you so much for watching from Try to Be Useful, and we'll see you in our next chemistry video.